When we suspect there is some element of causation at play, the true heavy lifter is regression. Regression analysis tells us the amount of influence some independent variable has on a dependent variable. Theoretically, an independent variable can be any type, though continuous variables are easiest to interpret. The dependent variable must always be continuous. There are special techniques that allow other types, but they're pretty advanced, and we aren't going to cover those. In its most basic form, we have one dependent variable and one independent variable, and we regress the dependent variable on the independent variable. This is called univariate regression, not to be confused with univariate analysis. If we found a strong correlation between two variables, and we had reason to think there was some element of causality, we could put them in a regression model to get more information. The regression model would tell us about the slope of that line. But regression modeling is incredibly adaptable, and it's most common to build up multivariate models. And there's theoretically no limit on the number of independent variables you can include. This is a good thing, since as we noted, rarely is one thing the sole cause of something else. Often it's a variety of factors. Note, though, that you can only ever have one dependent variable at a time. If you have multiple dependent variables in your study, you will have to run separate regression models for each one. Also, make sure you have a reason for any independent variable you include. It's tempting to take a kitchen sink approach and throw everything in you can think of, but often this just makes things more confusing in the end. Interpreting regression output is a lot more involved than we've seen so far, but there are really three key things to focus on, regardless of how many independent variables you include. The first thing you should always look at in a regression model output is the R-square value of the model. The R-square tells us the amount of variation in the dependent variable explained by this model. The rest is what we call error. It is the square of the correlation coefficient. So the closer to 1 means a better model fit. If the R-square is very low, we can generally chuck the entire model, as it doesn't explain much of what's going on in the dependent variable. The next thing we look at are the p-values of each variable included. We interpret these the same way we've been interpreting p-values already. The only difference is we now have multiple p-values to look at, and we may find that some variables are significant and some are not. A note of caution here. Just because a variable has a p-value indicating it isn't significant, we might still have reason to keep it in the model. Perhaps preliminary analyses indicated that it was significant, or perhaps we have a theoretical reason it may be important. Sometimes we find that by itself a variable is significant, but when included with something else it no longer is. That in itself is an interesting finding. One good way to know whether or not to keep a variable like this is to look at the R-square value. If the R-square is essentially the same whether that variable is included or not, then it can probably be tossed. But if including it changes the R-square, it's still doing something important in the model overall, even if that variable specifically doesn't impact the dependent variable. Finally, for any variable that shows significance, look at the coefficient or estimate. The coefficient tells us how much of an impact that variable has on the dependent variable. The way to read it is this. For every stepwise increase in that variable, we can expect an increase of whatever the estimate is in the dependent variable, holding all other variables in the model constant. Because this gets a little bit involved, your analysis assignment for this week is not going to have you doing this in R. Instead, I'll give you some examples of regression analysis output, and you can get some practice interpreting those tables. And if you think you might be using this for your project, we can talk about how to do that one-on-one.